we'll solve some problems of Mohr Circle. Okay, a series of direct shear tests was conducted on a soil. Each test was carried out till the sample failed. Okay, the following results were obtained. Sample 1, 2, 3 corresponding normal stresses and shear stresses given here. Okay, determine the cohesion intercept and angle of shearing resistance. Okay, എന്തൊക്കെ കണ്ടുപിടിക്കണം? Cohesion intercept and angle of shearing resistance. So first you draw a graph. Okay, here normal stress in this axis and then shear stress in this axis, which is a tau. Here it is sigma. Okay, then you mark 10, 20, 30, 40, 50. What is the range here respectively for shear stress? And then you plot the graph. Okay, 3 samples are there, 3 graphs. Then you draw a line here. Okay, a slope line. Okay, ഇവിടെ touch ആവുന്ന വരെ, the way it touches this axis. Okay, then you get from by using the protractor, by keeping it is in this level to this level. Okay, you get the angle here. What is the given angle? That is phi. That is angle of shearing resistance. Then you have the cohesion intercept C. So C is from 0 where it meets. Okay, where this slope meets into this axis, that is taken as cohesion intercept. Here it is 11. Okay, so C is equal to 11 kilonewton per meter square. Okay, next one, the following results were obtained from a series of consolidated undrained tests on a soil in which the pore water pressure was not determined. Okay, determine the cohesion intercept and the angle of shearing resistance. Sample is given, confining pressure is given, deviator stress is given. Okay, for 3 samples. So confining pressure is sigma 3. Okay, so deviator stress here is sigma d. So what is major principal stress? Sigma 1. Sigma 1 is equal to sigma 3 plus sigma d. So what do you do? 600 plus 100, 700 respective for all the samples. Okay, then in the question, I think it is it is asked only for one. Okay, so it is cohesion intercept and angle of shearing resistance. Okay, direct question. Okay, similarly you draw here axis, you draw the shear stress and then normal stress and the shear stress here. So you have to take this. Okay, how do you take this semicircle is like you add sigma 1 plus sigma 3 divided by 2. Okay, 700 plus 100 divided by 2 is 800 by 2, 400. Okay, you take 400 as the center and you draw an arc here. Okay, corresponding value with 100 and 700. You got the center here, right? The point will start from 100 and it'll end at 700. As you have added that divided by 2. Right. Correspondingly, you do it for the second one, third one. You get 3 arcs here. Okay. From this, you draw after getting this 3 circle, you draw a tangent corresponding to the axis. Okay, this axis. So you got an angle here. Okay, that is phi. Okay, then we have to find the cohesion intercept like the previous question. It is from 0 to what value it intercepts here. Okay, it is 150 kilometer per meter square. Okay, a series of consolidated undrained CU triaxial test was conducted on an over consolidated clay and the following results were obtained. So there are 3 samples. Cell pressure is given, deviator stress is given, pore water pressure is given. Okay, plot the strength envelope in terms of total stresses and effective stresses. You have to plot the graph for both total stress and effective stress. So you have sigma 3 as 125 cell pressure and deviator stress you have sigma d here, and then sigma 1. Okay, what is sigma 1? Sigma 1 is major principal stress, right? That is sigma 3 plus sigma d. What u is given, right? Minus 70. So sigma 1 dash, okay, for effective stress it is given sigma 1 minus u. That is 635 minus u. Here as it is given minus 70, you take it as minus 70. which we have to add, right? 7 not 5. Then sigma 3 dash, sigma 3 minus u, go to sigma 3 123, minus of minus 70, you add it 195. Okay, similarly you go do for other sample, and then you plot a graph. Okay, you plot a graph for total stress and then shear stress, right? So similarly, like in the previous problem, you have to add sigma 1 plus sigma 3 divided by 2. You take the you get the value here. Okay, from that point you draw the semicircle to the whatever point request. See, 125 and 635, right? You do semicircle here. Then for 870 and 250, you draw another one. For 1350 and 500, you draw another one. So you got 3 semicircle, right? Then you draw a tangent touching all the 3 points of the circle. Then you get here 5 you get as 19 degree and C as 140. Okay, so the question was for both. You have to find plot the shear strength envelope for total stress and effective stress. Okay, similarly for effective stress, the graph is not clear in the KT notes. I think better you refer Aurora textbook. Okay, at least you take a photo of that textbook question, so that you will be clearly able to understand. Okay, so effective stress, similarly you draw sigma dash and tau. Okay, similarly sigma 1 plus sigma 1 dash plus sigma 3 dash divided by 2. Whatever the value gets, center you will take and the corresponding curve you do. Then for the second sample, third sample. Okay, you get 5 dash as a value, and then C you take from 0 to whatever point this intercepts. Okay, you got shear stress. So plot from 1, total stress and effective stress. Okay, this is a simple problem which you will be able to understand. You can do it by yourself. Okay, another one. The stresses on a failure plane is in a drained stressed on a cohesionless soil are given. Okay, normal stress is given, sigma is given 100 kN per meter square. Then shear stress is given tau 40 kN per meter square. Determine the angle of shearing resistance and the angle which the failure plane makes with the major principal plane. Okay, find the major and minor principal stresses. Okay, so only two values are given. Okay, so what do? You take this axis, you take total stress, and this axis you take shear stress. You can take it as point 10, 20, 30, 40 till whatever 150 you draw it. Okay, and then up in this axis 10, 20, 30, 40 corresponding. Okay, what is given? Only 140 is given, right? So you mark where 140 meets. Okay, from here shear it is 40, you get a point here. Okay, corresponding to the 100. Okay, the point is here. Okay, then you draw a line. Okay, first you mark these points. Okay, 14 ഉം 100 ഉം എവിടെയാണ് മീറ്റ് ചെയ്യുന്നത്. ഓക്കെ, ഈ 40 ഇവിടെ ആയിരിക്കും, 100 ഇവിടെ. അപ്പോൾ കറസ്പോണ്ടിങ് ആയിട്ട് എവിടെ ടച്ച് ചെയ്യും? ഇവിടെ ഒരു ഈ പോയിന്റിലായിട്ട്. ഓക്കെ, then you draw a line. Okay, you draw a line like this. Okay, that is coordinates are 140 in the point A. Then you have to find major and minor principal stresses, right? You take your protractor. Okay, you keep the protractor you have to keep your protractor like this. Your protractor is in this shape, right? Adu tirichittu vekkanam. You have to keep it here like this. It should be right like this. It will be okay. If you want, I'll do a demo video if you don't understand how to keep the protractor. Okay, then corresponding 90 degrees taken from this point. We take a 90 degree. Okay, ഈ ഒരു ഇതിന്റെ മുകളിൽ ഈ ലൈനിൽ വെച്ചിട്ട് ഈ പോയിന്റ് എ നിന്ന് 90 ഡിഗ്രി വരയ്ക്കണം. ഓക്കെ, പ്രൊട്രാക്ടർ ഈന്റെ മുകളിലാണ് വെക്കുന്നത്. ഈ ലൈന് കറസ്പോണ്ടിങ് വെച്ചിട്ട് നിങ്ങൾക്ക് 90 ഡിഗ്രി ഫൈൻഡ് ഔട്ട് ചെയ്യണം. ഓക്കെ, അപ്പോൾ ഇവിടെ നിന്ന് ഇറ്റ് വിൽ ബി coming from this point to here where 90 degree touches in this axis. So it is taken as C. Okay, After that, you can draw semicircle. Right, you got the radius, and you can draw the semicircle. Okay, you can name it as B and D. Okay, so you get the major and minor principal stresses here. Okay, that is true graph. Okay, the above figure shows the Coulomb failure line passing through the origin and the point A with corresponding 140. So tan phi, okay, you take it as 40 by 100. Phi is equal to tan inverse of 40 by 100. Okay, you have to, you have to find the angle also. Okay, so phi is taken as, phi body get 21.8 degrees. So we have a formula, angle which failure plane makes with the major principal plane. Okay, that is theta is equal to 45 plus phi by phi dash by 2. That phi dash is taken as 21.8. Okay, so what do you get? Theta 55.5 degree. Okay, theoretically you get that. Okay, the center C, that is of the Mohr circle, is located by drawing a normal. Okay, that ഇവിടെ നമ്മൾ ഇത് വരച്ചില്ലേ ഈ പോയിന്റ്, ഇത് വരച്ച എങ്ങനെയാണെന്നാണ് പറയുന്നത്. The center C of the Mohr circle is located by drawing a normal AC, okay, to line OA. Okay, at A. Mohr circle is drawn to point A with its center at C. Okay, ഇതിന്റെ radius എടുത്തിട്ട് we draw this Mohr circle. Okay, the circle cuts at sigma, normal stress axis at point B and D. So from the figure you get sigma 3 as 73. Okay, here you get say 73 and here you get 159 kilonewton per meter square. And then for proving this you can do theoretically. Okay, if it is asked you can do it, or else for the confirmation that നിങ്ങൾ ചെയ്തത് correct ആണോ എന്ന് check ചെയ്യുക. Okay, length OA is equal to sigma square root of 100 square plus 40 square. Okay, OA കിട്ടി. പിന്നെ അങ്ങനെ തന്നെ AC, OC, DD, OB. Okay, ഓരോ ലെങ്ത് ഇത് നിങ്ങൾ you have to do it. Okay, ഇത് ട്രൈ ചെയ്ത് നോക്കണം ഈ പ്രോബ്ലം, otherwise you will be finding it difficult to solve it in the exam. Okay, corresponding values വെച്ചിട്ട് just try to calculate it. You get the same nearest value of what you found in the graph. Okay, that's it. I think Mohr circle problems.